Road to Olympiad.
Welcome to RTO. Consider the following problem. Given that a and b are positive integers such that when a squared plus b squared is divided by a plus b, the quotient is q and the remainder is r. Find all ordered pairs a, b such that q squared plus r is equal to 1987. The difficult part of this problem is we do not know what number is a and b, as well as q and r. So which one to start first will be the key point here to tackle the problems. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that by using the division algorithm, the given conditions can be written as a squared plus b squared is equal to q times a plus b plus r. Dividing the equation by a plus b gives us a squared plus b squared over a plus b is equal to q plus r over a plus b. This is less than q plus 1 since the remainder r is less than the divisor a plus b. Notice that the quotient q must be at most 44. Else, if q is at least 45, we have q squared is at least 2025, which implies that r is negative from the conditions q squared plus r is equal to 1987, which is a contradiction. With q is at most 44, we know that a squared plus b squared over a plus b must be less than 45. Now, we are going to claim that q must be equal to 44 and not others. To do so, we see that if q is at most 43, we have q squared is at most 1849. This implies that r is at least 128 from the given condition again. And this gives us the divisor a plus b, which must be greater than the remainder, must be greater than 128. Without loss of generality, we can assume that a is at least b. And then, we must have a must be at least half times a plus b. Here we consider two cases. Case number 1, if a is at most 2 over 3 times a plus b, which we can rearrange into b is at least 1 over 3 times a plus b. This gives us a squared plus b squared over a plus b must be at least half a plus b the whole thing square plus 1 over 3 a plus b the whole thing square, the whole thing over a plus b, where the right hand side can be simplified into 13 over 36 times a plus b. With the fact that a plus b must be greater than 128, we have 13 over 36 a plus b must be greater than 46, which contradict with our fact that a squared plus b squared over a plus b must be less than 45. For the second case, if a is greater than 2 over 3 times a plus b instead, we again have a squared plus b squared over a plus b, which is greater than or equal to a squared over a plus b, must be greater than 2 over 3 times a plus b, the whole thing square over a plus b, which can be simplified into 4 over 9 times a plus b. Again, with a plus b is greater than 128, we have a squared plus b squared over a plus b must be greater than 56, which gives us a similar contradictions as in case number 1. As a whole, this implies that q can only be 44. And solving the equation, q squared plus r is equal to 1987 gives us r is equal to 41. Putting them into our very first equations give us a squared plus b squared is equal to 44 times a plus b plus 41. This can be further simplified into a minus 22 the whole thing square plus b minus 22 the whole thing square is equal to 1009. It can be easily checked that the only way to get the sum of square is equal to 1009 is by 28 square plus 15 square. Solving for a and b by using both positive and negative value of 28 and 15, we have the possible solution for a and b are 50 and 37, 50 and 7, 37 and 50, as well as 7 and 50. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.